Good morning to all the participants. Once again, I am inviting that Bazila Banu, Madam, Resource Person Dr. Bazila Banu. She is a well-known expert from yesterday class. All. Okay. Now the session hand over to Bazila, Madam. Madam, please.
Yes, sir. Good morning to all. I take this opportunity to thank all of you for your wonderful presence. So for today's session, we are going to discuss about CNN and deep learning with some sample data set. So probably this will help you to do research related activities more with directly by using the data set. I'll just proceed towards the session. I'll present my screen. One of you please confirm whether you are able to see the screen. I hope my screen is visible to you.
Yes, ma'am.
Thank you, sir. So, so we are going to discuss about the neural network introduction and what is the role of deep learning in neural network. So just an overview of what is neural network. It's a highly structured, there is a layer. It is a part of machine learning technique. Always neural network is also considered to be a part of a machine learning technique. So here the neural network is widely used for various applications, especially when you deal with complex data analysis. That is, if you feel that your data set contains too many attributes, it means that my data set have so many features like 25 to 30 features. In that case, analyzing the data set using normal machine learning algorithms by performing classification or clustering techniques is very hard because the accuracy may less. So in that case, much training is required. So if you handle high volume of data or the data with more features, then better you just go with the concept of neural networks for classification. So you can apply neural networks both for classification as well as for prediction. Uh, Participant, please mute your mic. It is creating disturbance. Okay, thank you. So whenever you handle a large volume of data set or you handle a data set with more features, especially when you apply the concept of classification as well as prediction, better you go with the concept of neural network as well as deep learning. So you will be able to achieve very good accuracy as well as your model will be stable. There is always the result of classification and prediction will be high, more accurate. So better go with the neural network concept. So neural network can be applied for classification as well as prediction. So it's a highly structured layer. It consists of so many layers, not only the input and output layer. In between, we have a layer which is called as a hidden layer. So the first layer, whatever we have, it's called as input layer, and the final layer is called as output layer. In between, whatever the transaction that occurs, that layer is considered to be the hidden layer. It is similar to the spinning concept. There is something like web. So the hidden layer, what the hidden layer will do means probably whatever the input that you are supplying, that is processed by the hidden layer, that is highly activated by the hidden layer once again, and your input will be converted into or fine tuned into a different version of another input. So that is what normally it's happening. But we used to say for understanding purpose, we will get one output from the hidden layer. But what this hidden layer is doing means it is activating the input, whatever you are supplying, and it is regenerating your input. So your input will be much better, and you can get a better accuracy whenever the particular input has been processed after the hidden layer. So this is what the thing happening inside the hidden layer. So first you are going to pass the set of inputs. Okay, so this inputs will be supplied towards the hidden layers. Now what the hidden layer will do means it will perform some activations. Okay, so I will explain what kind of activation it will do. And after applying these activations, your input has been processed and finally it is supplied towards your output layer. Next question is how many hidden layers I can have. This is the normal question that anyone will ask. That is, I just want to fine tune my input. So can I go with one hidden layer or two, three, like that? Okay, it probably depends upon the accuracy. Whenever you want to have a better accuracy, you can increase, you can add the more number of hidden layers. Just start with 2 to 3 hidden layers, and still if you feel that your algorithm has not met with the much accuracy, in that case you can add one more layer. So that is the thing that we can do it whenever we design the hidden layer. So don't add too many hidden layers initially and execute the program. That will also increase your processing time. So don't add too much hidden layers. Just add the hidden layer that is slowly. Whenever you want to achieve more accuracy or better accuracy, in that case you can fine tune that. So if you are able to achieve the accuracy within 2 hidden layers, then you can stop the execution. So the output layer, what you do in the output layer means finally we will get outputs consolidated from the hidden layer, and this output layer has been used for determining the classified results. So how we are classifying the outcomes means it is determined based on the scores received at each output. For example, I have two outcomes here in the first diagram. So in the two outcomes, I received two outputs, that is class 1 and class 2. So class 1 has received a certain score and class 2 has received certain score. Based on the score, I am labeling the first one as class 1, and based on the score, I am labeling as class 2. Like that, based on the scores received, you can provide the outcomes. So this is just the overview. So now, how to calculate the overall cost that is required for the neural network construction means you need to calculate the actual output. What is the actual output that you need, and what is the output that has been generated? So both the outputs you have to compare. So actual output you can get it from your data set, whichever you split it as the test data set. So suppose I have 2000 records. In that I have 1500 records for training and 500 records for testing. Means I know the results of these 500 records. So I can consider these 500 records as the sample or test records. Now I'm going to pass this 500 records as an input, and I'm going to generate the output. So for this, whatever the output that has been generated, I need to compare the generated output with the actual output. So whatever the difference I have, that is the cost for the total training. So if anyone asks to find out the cost of the training, you need to subtract the difference between the generated output and the actual output. Thereby you'll be able to determine the cost of the training the whole network. So why we are using neural network, and why we are slowly moving to deep learning? People used to say about I have applied deep learning, but some used to confuse with the neural network concept and deep learning. Actually, deep learning is an extended technique of neural network. It means that if you design neural network with more number of hidden layers, then that particular technique is called as deep learning. For example, if I have two hidden layers and one output layer, that you can say that it is neural network. But slowly, if I add more number of hidden layers to improve my accuracy, then I can say that in my model I have applied deep learning. That's it. There is no much difference between the neural network concept and deep learning. Deep learning contains more number of hidden layers. So it contains, maybe you can have 10 hidden layers. So your complete model will take more time to process. So training will consume more time, but beyond that you'll be able to achieve better accuracy. So if you are handling very simple that is, you have a very simple data set, but there are more number of features. Just start with neural network, but don't start with too many hidden layers. If you want to improve the accuracy, then you add more hidden layers, and you can say that you have applied the concept of deep learning. So normally, whenever the data set is very simple, we used to consider the methods like SVM. That is, support vector machines are usually applied whenever we handle simple techniques. So if you want to have simple classification techniques, go with support vector machines, which is available in machine learning. If you are applying a moderate data set, if you feel that your data set is moderate, it contains some 10 to 12 features, and your data volume is with GB, in that case, you can go with deep neural networks. So if your data set contains volume with GB, then better you go with the deep neural networks. If your data set is still complex also, you can go with deep neural network, but just increase the number of hidden layers based on the requirement. So neural networks has been generally classified into three categories. The first one is convolutional neural network, second one is recurrent neural network, and third one is long short-term memory networks. So what is CNN? CNN means that is you are going to apply there is image related concepts, especially when you go with CNN rather than directly handling with text data. You can also use text data, but CNN will process all the images or whatever the data that you are supplying in terms of tensors, and finally it converts all the tensors in the form of matrices of numbers. That is, finally your data will be converted into the form of numbers, maybe some array like concepts, and it has its own dimensions for considering the data. That is, your data is not considered as such, rather your data will be considered in the form of matrices of numbers. So these numbers will be finally used for constructing the whole network. So they are not supplying the data. Suppose you are supplying a text data, means they will not consider the text data as it is. So you need to convert the text data into a numerical value, and all these numbers will be considered and constructed in the form of the array like format, probably the matrix like format, similar to the mathematics concept. So this matrices will be considered for the processing. So directly one-to-one input will not be considered. They will consider the input in the form of matrices. So these matrices are technically referred as tensors in image processing or in CNN. So maybe you might have come across the framework called as Tensorflow Framework, where they process all the images as well as the text data, whatever you are supplying, in the form of tensors. So tensors means it is nothing but matrices of numbers. So all the matrices of numbers are considered to be tensors if you are considering the matrix in a various dimension. For example, I can read the matrix in the row form, or I can read the matrix in the column form. Like that, I can consider the matrix in any size. Like if I have a 8 cross 8 matrix, I can consider only 2 cross 2, or I can go with 3 cross 3. So I can design the matrix in any form as I like, and I can read or I can split the matrix in any form. So that is why they are dealing with the concept of matrices of numbers, and this matrices of numbers are technically referred to as tensors, because whenever we process image or we process the text, we are not directly considering the text or images. So after this processing, these data has been referred as tensors. That is the reason why they have discovered a new framework which is called as a TensorFlow framework, particularly for processing all the images as well as your text data. So CNN, just repeat, CNN always consider the data in the form of numerical value. It will not consider the text number or category or any particular format. It will consider the input only in the form of numerical value. So next, let us discuss about the whole architecture of CNN, so that it is easy for us to go ahead with the programming part. So first of all, we have an input. For example, in this application, the objective of my application is to detect an object, whether it is a car or it's a bicycle or truck. So I'm just giving the input of all images. My final outcome is I just want to detect the object as either car, bus. So I want the classification of all the vehicles. So this is what my requirement. So the input I'm supplying is the image data. After that, what are the different layers that I have in my CNN? So CNN consists of majorly two phases. The first phase is called as the feature learning phase, and second phase is called as the classification phase. So feature learning is the first phase, classification is the second phase. Feature learning will do the training part. So whatever the input data that you are supplying, everything is provided as input towards your neural network, and here the complete training will happen. So once the training is over, if all the features present in the data set has been learnt by your machine, and after that it will be able to detect or classify the particular object. So once the feature learning is over, the next step is classification. So feature learning is the main concept behind the training part. So feature learning consists of certain sub concepts. First one is convolution layer. Second one is ReLU. Third one is pooling, and these three are combined together to form the feature learning. So convolution. There is after that we apply ReLU and pooling. I will explain one by one. After that we can go with the second phase, which is called as classification. So let me go in depth towards the first phase known as feature learning. So consider I have provided image as the input. So this image has been converted towards the matrix form. So I read the image in the form of the matrix form. Okay. So assume this is the input image, which I have read it in the form of the matrix form. So assume this is an 5 cross 5 input image. I'm just applying. So now the first phase, feature learning. What they will do in the feature learning means my image needs to be multiplied with certain filters. Okay, so I need to get a new type of image, because whenever I supply an image, this image cannot need not to be in a fine-tuned format. The image may be in a blurred format, or it may be in a colored format. So I just want to process the image into a different version. And here comes the question, what kind of processing I can do it? So the processing can be done with the help of certain filters. So you need to identify what kind of filter that you have to apply based on your requirement. For example, if I want to detect only the edges, then I have to select one filter. If I want to identify only the particular portion present in the picture, for example, eyes, nose, like that, in that case I need to apply a separate filter. If I want to convert the image into a blurred form, then I need to identify a different filter. Like that, based on your requirement, there are a lot of filters available. You need to select certain filter, and this filter is also available in the form of matrix form. This filters has been designed based on the analysis for identifying the edges, for detecting the particular portion, and so on. So you can directly apply the filter, multiply this filter with the existing matrix, and after that you will get the result known as convolve feature. So this convolve feature is the final outcome of the there is a input image. So this image has been processed and you are getting the output as the convolve feature. So the filters can also be referred as the kernel or feature detector, because this filter is a very important part whenever you process an image. That is why they are calling this particular filter as a feature detector. As I said, if you want to detect an eye, if you want to detect a particular portion present in your whole image or picture, then definitely you need to apply the concept of filters. So let me show that. And before that, what are the different size of filters available? This is also designed by the programmer. That is based on your requirement. You have to select the size of the filter. Either you can go with a 1 cross 1 filter, or 3 cross 3, or 5 cross 5, 7 cross 7. Like that, you can select the odd number of filters for multiplying the input image. Why we have odd number of filters means, in matrix if I multiply, I just move with the column wise. So definitely I need there is a odd number of filters to perform this kind of multiplication. That is why they have designed the filter sizes 1 cross 1, 3 cross 3. When demonstration goes, you'll be able to understand. So these are all the different filters available for feature learning. For example, as I said, if you want to detect a particular object, That is, identify the particular object, then apply the filter known as identity. So based on the operation that you are doing, select the filter. So for identity, there exists a filter with the matrix 0, 0, 0, 0, 1, 0, 0, 0, 0. That's all. So you have to directly apply this particular matrix whenever you want to perform object identification or identifying a particular picture or image, whatever it may be. So the operation you are performing is identity. So for that, the corresponding filter available is this one, the first one, 0, 0, 0, 0, 1, 0, 0, 0, 0. So this is the example image they are showing. You are able to identify the images there. Suppose you want to perform edge detection. There are a lot of edge detections available. Sometimes only the corner of the image can be viewed. Sometimes only the border portion of the image can be viewed, or sometimes all the edges present in the whole picture, like eye surrounded, then finally the face surrounded with an edge. Like that, you can mark the whole picture with edge. So there are three type of edge detections available. So based on your requirement, you can select any one type of edge detection. Suppose you want to apply sharpening technique, you want to sharpen the image, then you apply the sharpen filter, which is 0, -1, 0, -1, 5, -1, 0, -1, 0. If you want to normalize your image, that is, if you want to apply box blur technique, that is, if you want to make the image into a blurred portion, okay, somewhat dim, okay, in that case you can go with this type of filter. Then if you want to apply Gaussian blur, it is still something like a photographic view. So in that case also you can apply a filter. So like this, there are a lot of filters still available. I have only few things. So you can select any one of the filters based on your operation, and please proceed with that. So here I will show you the demonstration how this convolute layer is obtained. So first of all, I said that I have an input image with 5 cross 5. So this is my input image, and I have selected one filter, which is 101010, which is nothing but so I have selected one filter which consists of 101, 010, and 101. This is the filter I have selected to get the convolve feature. So I have selected the filter size as 3 cross 3. Okay. So now what I'm doing means you are supposed to multiply this 3 cross 3 filter with all the 3 cross 3 input present in your input image. For example, the first one, 1, 2, 3, 3, 4, 5, 5, 6, 7. So first 3 cross 3 matrix you have to consider and multiply the 3 cross 3 filter, and you will get the result as 4. Then simultaneously you have to consider the second 3 cross 3. That is first row, then navigate to the first column, then navigate to the second column. So from the second column you just construct the 3 cross 3 matrix. Similarly, from the third column you just construct the 3 cross 3. So after that you shift your rows. Okay, so once you have completed, you just shift your rows and then go ahead with the same operation. Like that, if you proceed, so here they are just shifting the 3 cross 3. So every time for each 3 cross 3 multiplication, you will get a result here. So for first 3 cross 3 multiplication with the filter, I will get the result as 4. Second 3 cross 3, I will get the result as 3. Third 3 cross 3, I will get the result as 4. So like that, if I perform the 5 cross 5 matrix with the 3 cross 3, then I will get another result which is called as 3 cross 3 matrix. So this 3 cross 3 matrix is referred to as the convolve feature. So that I have finally done with the convolve feature in order to proceed with the object detection technique. So once I receive the result, I can go to the next step. So any queries in this particular step? Able to follow? Any queries? Is there any threshold number of hidden layer which separates deep learning from neural network? Obviously, sir. There is normally a neural network, they will have 3 to 5 as the benchmarking when you consider neural network. If you go beyond 5 neural network, normally you can say that you have applied deep learning concept.
Ma'am, based on what that filter matrix is defined? How to define that filter matrix, ma'am?
Your picture, madam. Filter matrix you are asking?
Filter matrix.
Filter matrix based on the input image. For example, if I have a 5 cross 5,
Ah,
then I have to go with the 3 cross 3. The reason is, if I said that you have to multiply all the complete matrix with the result, right? So if I select 3 cross 3 only, I will be able to complete the whole matrix multiplication logically, right? If I have 5 cross 5, if I
mm,
apply 3 cross 3 only, I will be able to complete the whole matrix. See the
mm,
navigation, how they are doing.
mm.
You should not leave any one input without performing the calculation. You have to complete the whole input matrix. So if I select 3 cross 3 only, I will be able to proceed.
Ma'am, for example, if we take that image of size 7 by 7,
Mm.
and then what about the filter size? Shall we
Ah,
I think we can go for 3 by 3 and also 5 by 5.
yes, madam. That is your choice. You can go with
Okay.
3 by 3 or
So
5 by
what is the difference between choosing either of that 3 by 3
5.
or 5 by
There is
5?
3 by 3 or 5 by 5. 3 by 3 means you will get minute convolute layer. That is, even you will be able to identify the minute edges or minute corners also if you go with the less number of filters. If you increase the filter size 5 by 5, 7 by 7, then the features, whatever you are identifying, will not be that much fine. Suppose if your input image is also large and your filter size is also large, that will work perfect. If your input size is normal, you have to select a normal filter only. You got it, madam?
So it's nothing but
Because
I think covering minimum space,
yes,
covering I
for
think
example,
minimum
if you are
space.
considering the face of a human being,
Yes.
if you want to detect only the eye portion, then you need to cut that particular matrix, right?
Mm,
If you want to pinpoint only the eye portion,
mm,
then the whole face can be divided into so many parts. So
mm,
if you go with very large filter, means what will happen? The nose will also be covered in in that
mm,
position. So
mm,
you will not be able to get that minute feature.
mm,
So if you want to get minute feature, then go with the normal filter size based on your input image. If your input image is also very large, very
mm.
big picture, then in that case, you can increase the filter size also.
Okay, ma'am, okay. The space what we are choosing only deciding that the filters
Exactly.
size.
Exactly.
Okay, ma'am. What are we doing with? So this is another representation of that this actual image. This convolved feature is. Am I correct,
Yes,
ma'am?
madam. There is another representation, but this contains the fine-tuned feature. That is all the features are perfectly identified whenever I get the convolve feature.
Actually, what should be the maximum value to be received for each that is each matrix when it is filtered? Here we are getting the first cell. We are getting to the most 4, ma'am.
4. It
How
is just a
much?
multiplication, madam. That is
Ah,
one second.
how much to the maximum we can get? All once means.
No, no, it is not a maximum value. It is just a multiplication, madam. For
Ah,
example, first consider the first 3 cross 3 you consider. I
ah,
have the filter as 101, right?
ah,
So first cell you multiply with the filter 1
ah.
into 1 plus 1 into 1 plus 1 into 1. Like that, you do the multiplication.
Yeah. So
So it is
what
just a
filter?
matrix. So
Ma'am,
whatever the result that you are getting, that is the 4. So 1
okay.
into 1 plus 1 into 0 plus 1 into 0 plus 0 into 1 plus 1 into 0 plus 1 into 0 plus 0 into 1 plus 0 into 0 plus 1 into 1. This will give me the result as 4.
Oh, ah.
Similarly, next 3 cross 3, just perform the matrix multiplication. 1 cross 1 plus
That
1
is
cross
okay, ma'am.
1.
Actually, what should be the maximum of that? I think if all once in the matrix and also in that filter matrix, then it becomes the maximum. 9 will come.
I couldn't get what you're trying to say.
Actually, each cell in that convolved feature matrix,
Uh-huh.
if all once in both the matrix, filter matrix and also in that given image, it becomes 9.
Okay.
Each cell becomes 9. Am I correct, ma'am?
Okay. So you're saying that if I get maximum number, what should I do? Don't
All
worry
one.
about the number right now, madam. Whatever the number that you're getting, you just keep it as it is. So
Okay.
convol feature is just a multiplication of your input image with filter. That's all. You are not going to do anything with that, and don't worry about the number, whatever you are receiving here, because we need to have further steps also. I will explain what you
Ma'am,
asked.
one more thing, miss. You have chosen that filter as that is like a 10001
Yes, ma'am.
010, that filter. Why not? Is it that is? Shall we choose some other filters, ma'am? Which is
Yes,
other
madam.
value?
That's what I said. You can go with
Okay.
any filter. If you want to
Okay.
perform edge reduction, there are a lot of filters available. Since it's
Okay.
presentation, I have just showed you few filters. There are a lot of filters available. If you search by search CNN with for filters, if
Ah.
you search that in Google, you will be able to get what are all the different combinations of filters available. There are a lot of filters available, and still people are working separate research how to create the filters. It's again a research part.
That
People
is
are
what that
designing the
combination
filter.
of ones and
Yes,
zeros.
madam. So you can go with any type of filter. To improve the image processing techniques, people are designing so many filters.
How
So
to
you
choose, ma'am? What criteria to be taken for
they
choosing
have
the?
given the operation. Based on the operation, you get, for example, if you are applying identity, there are a
Okay.
lot of filters available. If you are applying the operation called as edge reduction, there
Okay,
are a lot
ma'am.
of
Okay. Thank
filters
you, ma'am.
available.
Thank you. Now
So
clear.
based on the operation you are performing, select the filter.
Okay, ma'am. Okay, ma'am. Super. Now
Since
clear.
it's PPT, I have just showed you only
Okay,
four.
ma'am. Okay, ma'am.
I
Okay,
don't
ma'am.
have
Now clear.
space. So
Thank you. Thank you.
I'll share you a separate link to search for the filters.
Okay, ma'am. Okay, now clear, ma'am. Thank
Shall
you.
we proceed towards the next thing?
Yes, ma'am. It's now clear,
Okay.
ma'am. Thank you.
So the convol feature normally depends upon three parameters, madam. That is how this convol feature is generated means it depends upon three parameters. The first one is the depth. That is the depth is the input image whatever we have considered. It's 5x5, right, madam? So
Mm.
each picture it contains certain colors like RGB. So
Mm.
based on the color also the resultant convolute feature depends. Second one is stride, that is number of pixels by which we slide our filter matrix over the input matrix. This is the second concept. For example, you asked me a question like for 5 cross 5 I have generated 3 cross 3, right?
Yes, ma'am.
So what will happen if I go with directly with 5 cross 5 filter?
Mm.
Automatically I will get only one outcome, right?
Yes, ma'am.
So
Yes, ma'am.
this stride is the number of pixel by which we slide and we move the matrix over the input matrix for
Mm.
generating the convolute layer. So if you want to get very minute or small feature map, then
Mm.
go ahead with a, small filter, which we call it as a stride.
Okay.
Technically, they call this concept as a stride. Number of pixel by which you are moving the matrix.
Mm.
Then padding. That is how many pixel you add extra to the image. There is suppose if you feel that your image is so blurred, in that case you can add padding to the whole image. This is the initial
Mm.
process that you can do it. If your
Mm.
image is in very blurred condition, in that case
Mm.
you want to improve the image, then they ask you to apply the concept of padding before proceeding towards the convolute image. So these are all the features that depends on the result.
Mm.
So second phase is after getting the convolute image, I need to further process my image. Why I want to further process means there may be lot of negative elements or zero values that is present in the matrix. So I just want to replace all the negative pixels that is present in the image. So I need to further process my image. It may be a negative value or it may be a zero value. So whichever the value that is considered to be not required, I just want to replace all the negative pixels present in the image. Pixel wise, they call it as negative. So I just want to replace all the negative pixel values present in the feature. So this process is called as the rectified linear unit. Shortly, they call it as a ReLU. So
Mm.
this operation, why we are applying means just again fine tuning the convolute image, just removing all the negative pixels values present in my feature map. So this is the input feature map, assume I have. So whatever the black portions I have, they call it as negative, and white portions they call it as a positive. So first what they are doing means they are just removing all the negative pixels present in my, that is the black pixels present in my image. So this process is called as ReLU. So completely the black pixels present in the image, which is called as negative pixels, will be removed, and only the non-negative values, obviously we call it as a white. So the white color will be obtained as the output. So this particular output is referred to as the rectified feature map, because if we have so many black dots present in the image, then we cannot able to detect the particular object. This black color will make the whole image to be in a dark format. So identifying the object present in the image will be very difficult. So what they are doing means they are completely removing the black object. So technically they are calling the black objects as the negative pixels, all the white objects as the positive one. All the whatever the white value you have, white pixels you have, that is called as the positive values. So we just want only the white pixels, otherwise called as the non-negative value. So the final outcome of this ReLU is converting the convoluted image into the rectified feature map, which contains only non-negative values, so that identifying the particular object is very clear when I do this conversion. So this conversion is called as, otherwise called as a non-linear conversion, because it is not happening in a linear way. So because why they are calling this as a non-linear conversion means they apply an activation function to convert the input feature into the rectified feature map. So there are a lot of activation functions available to perform this conversion. I will show you those activation functions moving forward. So third one is a pooling layer. While doing the program, probably you'll be able to understand the complete ReLU. So the ReLU is one of the activation function where they apply the input image to process by converting all the white pixel values into the rectified feature map. So finally, they remove all the negative values. So third layer is called as the pooling layer. So after the rectified linear unit, your image has been completely that is eliminated with all the black dots as well as the black pixels. So your image now contains only the positive values. It means the non-negative values. So after getting the ReLU only, you have to proceed with the next layer, which is called as the pooling layer. So pooling layer, what we are doing means still we are minimizing or normalizing the whole image into a short form. This is what they are doing in the pooling layer. For example, if I want to detect the eye portion present in my image means what they are doing, finally we have a matrix for this eye format in the convolute image. Still, I want to concentrate only the particular eye portion by eliminating the remaining parts. So this can be done by minimizing the whole matrix into a normal form. So I'm just converting the convolute feature into a fine-tuned format. Okay. So assume after applying the rectified linear unit, I received the matrix in the form of a 4 cross 4. Okay, so this is the matrix I received after applying the ReLU concept. So now I received the matrix in the form of the 4 cross 4. I just want to apply the pooling layer, pooling concept. So pooling concept is very simple. So here I have, if it is a 4 cross 4 matrix, I have to consider each and every 2 cross 2. So from the 2 cross 2, I am just considering what is the maximum value present in the 2 cross 2. For example, 1, 4, 2, 6 if I have, among the 4 values, which is the highest value? 6 is the highest value. So I am considering only 6 as the outcome. Then second 2 cross 2, 2, 7, 8, 5, which is the highest value? 8 is the highest value. So I am considering only 8. 3, 4, 1, 2, which is the highest value? 4 is the highest value. So I'm considering 4. 0, 7, 3, 1, among the 4 values, 7 is the highest value. So now whatever the map I received, matrix I received now contains the pixel with high intensity. So that is why I have considered only the numbers that is with high value. So among the all 2 cross 2, I'm just considering only the number with highest value. So 6, 8, 4, 7 is the final pooled feature map, which shows my object in a clear way. So that is why they are going for pooling. So there are a lot of techniques in applying the pooling technique. One such technique is finding out which is the highest value in the 2 cross 2. This is one technique. Second one is taking the average of all the four values. For example, if I have 2 cross 2, just take the average of all the 2 cross 2, 1 plus 4 plus 2 plus 6 divided by 4 you do. What is the average value that you get? You just put it here. Like that, you can go with average. Otherwise, just take a summation of all the values. So this is the normal operations that we do when we want to convert or normalize the rectified feature map into pooled feature map. You can either go with maximum, taking the maximum value, or you can take the average value, or you can do the summation. But normally people will go for taking the maximum value. The reason is the maximum value, based on the research results, taking the maximum value is giving more fine-tuned object, the more fine-tuned feature. So most of the people, they are applying max pooling as the technique for pooling layer. But you can also go with average pooling and some pooling also. So this is the outcome if I apply pooling layer concept. So that's it. We have trained the first phase. So these are the three things that we have done it for training the neural network. So first I passed the input image, then I constructed the convolve feature, then I applied the ReLU as an activation layer to remove all my black dots as well as the non-negative pixels present in the image. After applying the ReLU function, I have generated the pooling layer. So now this is the outcome that I have received after completing the feature learning process. Now my system has been ready to identify the particular object, because I have trained all the images to identify the object based on the particular feature. So now my result contains certain features which can be used by the neural network to detect. So the feature learning step is over. Next, we can move to the phase 2, which is called as the classification. Now you can go with the classification concept. So here we are not going to do any processing of the image. So now the processing of the image, everything is over. Still, there is only one thing that is required. In the phase 2 classification, I need to apply another activation function, which is called as the softmax. So they call the activation function, which is called as the softmax function. So why they are applying this softmax function means, I just want to find out the score for each of the classifying object. That is, for example, if I want to identify the object as car or truck or bus, for each of the vehicle, I need to provide a certain score, and each of the particular vehicle has its own feature. So what I'm doing means, among the whole results, I'm applying another activation function, which is called as softmax, to get the final output layer. And this softmax function will give me the final result to say that which particular object has the score. So based on the score, now I can evaluate. For example, if the score is 0.9, I can say it is a car. If the score is 0.8, I can say it's a bus. So this softmax activation function will calculate the real valued scores of all the objects present in the particular data set, and based on that you'll be able to detect the object. So this softmax is only applied in order to detect the particular object by calculating the arbitrary real valued scores. So now your final outcome is ready after applying the softmax function. So normally the phase 2 classification, it contains the traditional architecture, which we call it as a multi-layer perceptron. It means that rather than having one hidden layer, you can have more number of hidden layers for training the whole network. Now you are passing the image towards hidden layer 1 and 2, and you are applying the function which is called a softmax activation function to calculate the final score. So based on the score, now you are detecting all the objects. So this is the phase 2 classification that we are doing. I just want to cut short the theoretical part, because if you go through the program, you'll be able to understand much better. So we have discussed about few activation functions. Like in the first phase, we discussed about ReLU, and in the second phase, we have discussed about the activation function known as softmax. Do you have any idea about what is this activation function? What it do, and why we need activation function, especially when we deal with neural network and deep learning?
No idea, ma'am.
No idea. So now if you work in linear regression, or if you work in a support vector machine, any kind of machine learning technique, they will not apply activation function. They will directly give input, process, they will apply some kind of mathematical formula to generate the output. That's all. So here what will happen means, whatever the input that you are supplying, the output that has been generated, it depends upon the input. That is the output, whatever you are generating, it highly depends upon the input. Means if there is a change in the input, automatically there is a change in the output in a linear fashion. If the input increases, automatically based on that, the output will also increase, because both the variables are dependent on each other. So this kind of concept is called as linear fashion. But in case of neural network, we don't want the output in case of linear way. We just want to change the behavior. We want the output in the way of non-linear. That is, even there is a change in the input, either it may increase or decrease, the output has to be generated in a different format. It may increase or it may decrease, depends upon the features. So that is why we need the activation function. So this activation function is nothing but a mathematical formula we are doing. Normally in maths, we apply the concept called as derivation, that is a differentiation, right? So why we apply differentiation in maths? Any idea? So activation function is particularly, they apply the concept of differentiation logarithmic. There are a lot of activation functions available. And one such example only we discussed about ReLU, Softmax. These are all the activation function. It contains the mathematical formula only. So probably I'll just open the activation function and show you. Just a short introduction to activation function. This is required. I will share you this particular sheet. Whenever you go with neural network, you should know about activation function. So the purpose of activation function is, we just want to convert the output in a non-linear fashion. Whatever the input behaves, we just want to get the outcome in a non-linear way, not in a linear way. So always this activation function helps to do that, to achieve that better. So few activation functions are binary step function. So all are mathematical formula, linear function. So f of x is equal to a of x. It's a linear function. So x is my input. Okay. I'll just share this sheet. Please go through it. Sigmoid is another activation function. So then tan h is another activation function. Like that, ReLU is one of the activation function widely used in neural network. So like that, sigmoid, softmax. So all these are activation function. So here mostly if you see, they have applied a differentiation, logarithmic, that's all, exponentiation. So all these things they have applied for each and everything. So this activation function is another big concept you need to know about. So anyway, I'll just share this Word document. Please go through the activation function. I have explained here what is the input needs to be supplied for each activation function, and what is the outcome they are getting in a simple mathematical calculation. So please go through the sheet. I will share it with you. So why we need activation function means, we just want to regenerate the input into a various form. That is, we want in a non-linear way. That is the main reason. So the reason behind they have applied differentiation, exponential, logarithmic, all these concepts are because rather than considering the input value directly as x, if we do differentiation of x, what's happening logically? The input x is taking a next version. If we differentiate a particular value, we will get the next version of the input. If you do double differentiation, double integration, or exponentiation, you are just fine tuning the input into a various forms. So based on the mathematical concept, they have applied the activation function. So there is no choice in selecting the activation function. Basically, in neural network, they go with ReLU and softmax. But I will share you the list of activation functions applied. you can select any one of the activation function for trial purpose, and you can check what is the result of the activation function. In at any point of time, they have not mentioned that this is the suitable activation function for this kind of problem. There is no such research like that. You can select any one of the activation function based on your requirement. Suppose you are getting very good results for relu, then stop it. You can no need to try. Suppose you are getting very good results for tan h, then please apply. So you need to go in a trial manner to apply the or selecting the activation function. So I think this is enough about what is activation function. So just regenerating the input. So let me directly move to the hands-on session. Before that, we just want to give you an idea what are all the different frameworks available if you are applying deep learning concept in neural network. That is, these frameworks are built in Python. So if you want to apply deep learning, don't struggle, don't write more lines of program. Just apply this framework. You can go ahead with very simple way. Today, I will show you the TensorFlow framework, how to write programs in TensorFlow for deep learning. Then PyTorch is also another framework that is available for deep learning. Keras is another framework available. MXNet, CNTX, CAFE and CAFE2, Deep Learning 4J, Chainer. All these frameworks are open source frameworks you can apply to design your deep learning programs. So for today's session, I will just show you how to apply TensorFlow for building the deep learning network. So let me open the Colab and I'll show you the program directly. So here I have applied the diabetics dataset for training my neural network. So my diabetics dataset, it contains features like pregnancy, glucose level. I think you're able to see the data set. So this is the normal data set I have downloaded in Gaggle. So this data set contains pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, and the diabetics pedigree level, age, and these are all the inputs I have. Okay, so based on the A to H data, I just want to classify the particular patient is having diabetics or not. So the outcome I want is either 1 or 0. So this is a numerical data set, so I can directly go with the concept of neural networks. So these are all the features I'm considering, and this is the data set I'm going to supply for my neural network program. So the final result I want is whether the patient is having diabetics or not. So the I will get two outcomes, 0 as one class and 1 as another class. This is what the final outcome I need. So now I'm going to construct the whole model. So as I said, I am going to use TensorFlow and Keras for this particular program. So here, these are all the basic packages I need to import. So from Python, you just import pandas, NumPy, Matplotlib, Seaborn. So Matplotlib and Seaborn, these two packages, you can use it for data visualization. For example, if you want to display the results in a chart form or graphical representation, you can go with these two packages. So Matplotlib and Seaborn can be used to represent your data in a graphical form. Like you can go with pie chart, bar chart, any type of charts you can go whenever you use Matplotlib. Then if you want to divide your data set for training and testing, just go with a package called as sklearn. So from sklearn.model_selection, import train_test_split. So this is the sub package that is available under sklearn package. So this is used to divide my data into training and testing data. Same sklearn package also contains algorithms for classification, and I can get accuracy scores from the package known as sklearn.metrics. So directly I'll be able to get the accuracy score. Then if I want to do any pre-processing for the data set, I can go with the sklearn.preprocessing. So I can normalize my data set. Then coming to Keras, what this Keras contains means, if I want to design a neural network, I can go with the package called as keras.lib. layers. So keras.layers is used to design my neural network layer. That is an input layer, hidden layer, and output. I will be able to get in a layered format. So the package name is keras.layers. Then if I want to construct my model, I can go with keras.models. So keras.layers also contains the packages for activation functions. Then I can have other things like uh, batch normalization. I will explain all these things later. Then keras.models is used to construct the model. Then I can go with keras.optimizers to optimize the whole neural network. That is to fine tune my result. There are a lot of optimizers available. I have imported only one optimizer, which is called as Adam optimizer. Then keras.callbacks. This particular package is used to stop the iteration. For example, I can go with any number of iteration based on the result, right? So it is my logic to keep the number of iteration. For example, if we go with for loop like I is equal to 0 to 100, the loop will execute for 100 times. I can make 100 or I can make 50. It is up to my choice. But what happen if I get the result in 50th iteration itself? I can stop the execution rather than continuing the execution. So this can be achieved with the help of keras.callbacks. So even though I have given more number of iteration, I can stop the iteration by using this callback procedure. It contains two method packages, which is called as reduce LR on plateau or early stopping. So these two functions, what they will do means whenever the accuracy has been reached, there is the results of previous iteration will be compared with the current iteration. When the results are same, the program will not execute, it will stop. So the procedure is called as early stopping. So it will stop up to that. So that is why I need all these things. So here completely I have used Keras framework. So keras.layers, keras.models, keras.optimizers, keras.callbacks. Similar to that, you have TensorFlow also. TensorFlow also contains layers, models, optimizers, callbacks. So now moving to the concept, I have imported all packages. Now I am just loading my data set by using Pandas data frame. Yesterday I have explained how to load the data set. So since I'm using Collab, I'm just using from google.collab import files. Uploaded is equal to files.upload. So now I have successfully uploaded my diabetics.dataset. So diabetics.csv I have uploaded. So after uploading, if I want to see whether I have uploaded this perfectly, I can see by calling the method known as diabetics underscore df dot describe. So I will be able to see the whole results. There is whole data set I can see if I execute this particular line. So then what I'm doing means these are all just to basic visualization. That is just plotting the whole data into the form of plots. I just want to see the correlation between all the things. One second. 1 second, give me a second. I will just load the program with results so that there's no need to execute the program. It will take time. Thank you. So I have just got the results for all the lines. That is why. So here I have loaded the diabetics data set. Now I have typed the line dataset.describe. I just want to see whether I have properly uploaded. So I'm just reading the CSV file. So what is the pandas method that is available to read the file means I have uploaded. After that I'm reading the CSV file. So diabetics underscore df, this is a variable I'm creating. This is equal to pd.read underscore CSV. What is this pd means? This is the variable that I have created in the pandas package. So first of all, in pandas package, you just create a variable known as import pandas as PD. By using this PD, you can read the columns present in the data set. So PD.read CSV. Since my file is CSV, I'm just using the value CSV. Suppose you have imported Excel file, then you have to use the command read XLS. So this is a comma separated value file. So I am reading pd.read underscore CSV. Within the bracket, I'm just using diabetics.csv. This is the file that I have uploaded. So I am giving in double quotes. Then if I want to see the first 5 columns, the command is diabetics underscore df is the variable, right? Dot head. If I use the command dot head, I will be able to get the first 5 records present in my data set. So this is the thing that I can use to know about my data set. I have uploaded properly. Then the next command diabetics underscore df dot describe. This is used to know about the whole data set. Okay, so describe in the sense it will give you the consolidated result of the whole data. For example, how many count I have it for this particular attribute pregnancy. What is the count I have it for glucose? What is the mean I have? Standard deviation I have? What is the minimal value I have? And what is the percentile wise I have 25%, 75 max. So a description about the whole data set has been given whenever you call the command diabetics underscore df dot describe. So all these things will help you to understand the data. Then the next one is diabetics underscore df dot correlation. So this particular method you can use it to understand what is the correlation between the attributes. For example, what is the correlation between the attribute glucose and blood pressure? So you can able to see the matrix-like format. So the values will give you what is the correlation between each and every attribute. And this you can also done it with the help of graphical representation. One such graphical representation is called as, if you see through this number format, normally we will not be able to understand what is the correlation, because everything is number. We have to search all the numbers to find out which is highly correlated. So this is complex. In order to make it easy, you can go with the correlation analysis by using heat map. So heat map is one such that is plot that is available under Seaborn. Seaborn is the package I have showed you, right? Matplot and Seaborn are 2 packages. So from the Seaborn, you can call the method known as heat map. So heat map is used to you can understand what is the correlation between all the attributes or features present in your data set. For example, SNS is the variable that I have created in Seaborn. So SNS dot heat map, you are calling this map. Within the bracket, you need to pass the data frame. So diabetics underscore df is my data frame. Dot CORR, dot correlation. You have to call this method dot CORR, and followed by you just give annotation is equal to true, AX is equal to AX. That is, you are fixing the axis. Annotation is equal to true means all the column names will be displayed as such. So now, what is the outcome from the heat map? Anyone of you know about heat map, or you want me to teach heat map? Have you heard about heat map? It is the one of the best thing that you can use whenever you do data analytics. So heat map, you can able to understand what is the correlation between each and every attribute. Heat map will represent the data with various colors. Okay, so whenever I have very dark color, it shows that the variables are highly correlated.
Ma'am, it is highly correlated. When it is dark, like black one, it is highly correlated.
Yes, sir. So here
And,
you can also, yes, sir.
Ma'am, one more thing, like these 1 1 is nothing but a diagonal relationship.
Yes, sir. You are right. Because
For the
diagonally glucose,
corresponding
if I
element.
map it with again glucose, I will get the same value, right? That is why 1 1, all diagonal values.
Okay, ma'am, one more question. Like here it is 0.33 in glucose row and in the fourth column, and there was a one element 0.54 in the first row with the pregnancy. Okay, ma'am. So it is having an orange color and it is having this. So if the color changes here, like it is, I am not able to understand. This is a separate color, totally separate.
Mm-hmm.
So
Yes,
what
you
does
are
it
right.
mean? Yeah.
It's a separate color means they used to say the age variable is having the high impact on this pregnancy. So you
Got
have
it.
to map with the row and column. Whenever there is a change in color, like orange color, map the row and the column, corresponding row and column. So here, if you see, we have in the row wise, in the column wise, I have age, and the row wise, I have pregnancy. So what I can suggest means out of this, the age is having high impact on the pregnancy. So whenever I determine the glucose level, if the age is more and the person is pregnant, definitely there is a high chance for getting diabetics. That is what they are trying to conclude.
Okay.
Okay.
Okay. Thank you very much.
Okay.
Thank you.
Okay. So you are please, whenever you want to analyze the data, please go ahead with heat map. Definitely,
ma'am,
any complex data you can analyze. Yes, madam.
Ma'am, can you just repeat that? How that correlation was been done? I could not relate it.
That is, whatever the data set you have, you are just finding the one-to-one correlation for all the attributes, madam. For example, we have some 8 attributes, right? I just want to find out the correlation of one-to-one pregnancy with glucose, pregnancy with blood pressure. Like that, I want to find one-to-one in the reverse way. So one-to-one correlation can be found with the help of heat map like concept. So if so all your rows and columns are same. For example, in the row also I have pregnancy, in the column also I have pregnancy, means both are equal, right? So in the diagonal wise, I will get one value. Second column, I have glucose, right? So pregnancy is compared with glucose, the value is 0.13. Pregnancy is compared with blood pressure, the value is 0.14. Like that, we are just plotting all the values with 1 cross 1. Whenever you get dark colored in the heat map, it shows that the variables are highly correlated. So light color represents the variables are less correlated. So based on the intensity of the color, you can able to understand the relationship between the attributes.
So is that black color indicates the some correlation?
The black color indicates, if it is here, it is they have given 082, right? That is, you just compare with the values also, with the other values also. Here we have 0.5, which is high, right? So dark color in the sense orange color, some bright color you can see. So here they have depicted with bright orange color, right?
Okay,
So it means
understood.
that, yeah.
So in the first row we had pregnancy, and you're trying to say with the age, because
Yeah,
the
the
first was
0.54
compared to
map it to age, madam. So column I have given in the lower side. Okay, if I might have given in the first one,
Thank you
that
so
will be
much.
easy.
Yes, ma'am.
So, okay, the
Thank you so
column is
much.
age
Ma'am,
and row is
how
pregnancy.
the correlation is calculated, madam?
Sir,
How that correlation value is being calculated here?
how they are calculating the value? I'm not sure, sir. They are just using any mathematical formula, I think.
Any formula, correlation formula?
I don't know about the correlation formula, sir.
Okay.
Madam, is there
Ma'am,
any standard
excuse
color
me,
chart for this one?
Yeah, ma'am, can I answer this question? Ma'am, they use Carl Pearson coefficient correlation.
Oh, okay, okay. Okay, sir. Not only the SM coefficient, you can have any type of correlation formulas. Lot of correlation formulas
Yes.
available, sir.
Like Spearman's and all
Sir,
that. But basically we use these two in
okay.
this.
Any
Coefficient. So
correlation.
it's
Okay.
purely a mathematical formula, sir, to find out the
Yes.
correlation. So there
Yes.
are a lot of mathematical formulas available to find out the correlation between the
Maybe
attributes.
Because what happened,
variables that is to be
what happened in
But I specifically don't know which particular correlation heat map is applying. I don't know the inner part. Okay.
ma'am, it uses basically majority times when the variables are in proper control and manner, they use Carl Pearson, because in SPSS, while you go in the backside of their programming, they had done it in this way.
Oh, okay. So maybe Pearson coefficient like that. There are a lot of coefficients available to calculate the correlation, sir. So we are not very sure that which particular correlation technique the heat map is applying. I don't know about that.
Okay, thank you.
Okay.
Madam, is there any color chart for this heat map?
Color
Standard?
charts.
Yeah, for orange it means less, for black it means
Yes,
greater.
sir. That index has been given here, no, sir. Here you see the side one, they have given a
Okay, fine.
scale.
Okay.
So the scale 0.0, 0.2, 0.4, the scale increases, no, sir. Based on that, you can determine the color.
Means
Okay.
highly correlated.
Yes, this has been given
Ma'am,
in
this is
the,
diagram, ma'am.
From 0 means highly
Hello,
correlated. And 1 means highly correlated.
so highly correlated. It depends upon the dark color, madam. It doesn't mean that 0 or 1. So, for example, here the orange color has been identified as the highly correlated. That is a bright one, not the black and white, not like that.
So that means that there is no
Normally,
Hello, madam.
yes, normally the black, the scale decides. So here the black color is given in the top 0, 0, right? It is not that much correlated. It shows.
Yes, ma'am. Here thickness, skin thickness and pregnancies. I think
Yes,
skin
madam.
thickness.
Yes. So the
That
outcome of the heat
show
map
pregnancy.
we can detect is glucose levels had the highest effect on the outcome. So glucose is that is whatever the level that we have, it has the highest effect on the outcome. Similarly, the pregnancies is highly correlated with the age. This is what the two analysis finally we can get it whenever we go with the heat map. Like that, we can go with the more
Excuse
number
me,
of
ma'am.
analysis also. Yes, sir.
Excuse me, ma'am. Ma'am, this is diagram, ma'am.
Yes, sir.
Ma'am, can you able to hear?
Yes, yes, here.
Ma'am, all are the color palette all are default one.
You can
What is
change
the negative value represent, ma'am?
negative value, it represents
ma'am?
less correlation only. Negative value means it's less correlation.
There is no correlation.
There is no correlation.
Sorry. Okay.
Less correlation or very weak correlation. No need to consider that.
Is there any possibility to change the color, ma'am?
Yes, sir. You can do it with Matplotlib. You can change the color.
Okay. Can you change the color, ma'am? Okay. Thank you, ma'am. Thank you so much.
Sir, only 15 minutes time. I need to complete the neural network.
Okay.
Ma'am, where there is a minus sign
Weakly
in the correlation,
correlated,
that means there are two opposite
Yes, sir.
variables.
They are
There are
weakly
two opposite
correlated. Maybe
variables from
technically, if you say that weakly correlated, they are not at all related. Also, you can say.
Yes, ma'am. Yes, ma'am.
Okay, ma'am. Okay. Thank you, ma'am.
It is going out of level.
Yes, sir. It is going out of level. No need to consider the relationship between the attributes.
Yes, ma'am. Yes, ma'am.
Shall we go ahead? Still, I need to start with neural network.
Yes, ma'am. Yes, ma'am.
Okay, these are all data
Yes, ma'am.
visualization. There is I have simply depicted the results through plots. So you can go with the sns.count plot to see how many variables that we have it for class 1 and 0. So I have how many zeros present in the diabetics and how many 1 present in the diabetics. For this, you can use the plot known as sns.count plot. So it will give you me the total count present in each class. For example, diabetics_df.outcome is one of the data frame I have. So if I want to know how many outcomes are available in class 0 and class 1, I can go with a plot known as count plot. So this is another data visualization. So I will just skip all these things because first let me cover the neural network. These are all just a visualization concept. I have plotted the whole things and I have seen what is the impact of various things. Directly I go with the neural network concept. I thought of covering data visualization also, but I couldn't have time. Since it's 1.5 hour session, it's very short. So let me show the neural network construction. So first of all, we need to design the neural network, right? So first identify which particular column you want as the outcome. So among the 8 columns, whatever we have it in the data set, I want the classified result as outcome. So I have decided this particular column known as outcome as the final result. So I'm eliminating, I'm just dropping the particular column from my data set for classifying it, the results. So I'm creating my X, what is the outcome of the final classification. So X is equal to diabetics underscore DF. This is my data frame dot drop outcome is the column name, comma axis is equal to 1 dot value. So I am just identifying which particular attribute will act as the X value. Second, I am just considering all the values as the y part. There is a, here I have just considered the column. Then in the y, I am considering diabetics underscore df dot outcome dot values. So I am considering all the values separately and stored in the variable known as y. Now the second one is I am just splitting all the attributes for training and testing. For that, as I said, you can go with the package called as train underscore test underscore split. This particular package is available in sklearn package. So now I am just passing the x value, y value, and test size equal to 0.3, random state equal to 2. Test size is equal to 0.3 means my training data will be 70% and testing data will be 30%. It means that I have considered 70% for training in the whole data. If I have 500 records, among the 500 records, 70% of the records will be considered for training, and remaining 30% will be considered for testing. So I think you know about training and testing percentage. Normally we used to consider 75 is to 25. 75 for training, 25 for testing, or 80 for training, 20 for testing, or 70 for training, 30 for testing. So like that you can go. Don't go with 60-40 or 50-50 ratio. That is not that will give you less accuracy. So now I have given the testing sizes 0.3. It means that 30%. So remaining 70% of my data will be considered for training. Then the fourth variable random state equal to 2 I set. This is for because whenever I execute my program, always my program will take a different type of training data, because the training data will be shuffled every time. In order to avoid that, whenever I execute the program, every time I will get different accuracy result. In order to avoid that, there is a variable called as random state. So you just configure the random state to some integer number, random state equal to 2. You can give any number, 2, 3, 0, some numbers you give, some integer number. If you configure this particular parameter, it means that if you execute your program again and again, your training data set will not shuffle. Every time you will get the same accuracy. So that here I have designed my data for training and splitting. After that, what I'm doing means I'm applying the concept called as there is a transformation. I'm just transforming the data into the fine-tuned format. So I'm normalizing the whole data. So for this, I'm calling the method called as a normalizer. This is also available in the package known as scikit-learn. Then first of all, for training, I'm just doing this transformation. And for testing, you need to do it separately. So here, n1.transform, you pass the variable known as xtrain. So your data will be transformed into a fine-tuned format. So all the negative values, everything will be eliminated, and this transformation will help you to get the data in a complete numerical form. So I have done it for my training data, and after that you have to do it for your testing data also. So do these two tips separately. And then you construct the concept of hidden layer. So now I'm going to construct the neural network. So for constructing the neural network, I'm going to define a function. So defnn, this is the function I'm writing in Python to construct my neural network. Now, if you see how many hidden layers that I have constructed. So here I have only one input layer. So this input layer contains all the inputs, whatever I'm supplying. So name equal to inputs, shape equal to x underscore train dot shape 1. So this is the two parameters I'm just passing as for the input. And second one, I'm going to create a hidden layer. So the hidden layer will be constructed by with the help of 4 functions. So the first hidden layer, if you go through the first 4 lines, layer equal to dense, layer equal to batch normalization, layer equal to activation, layer equal to dropout. So these 4 lines of code will help you to construct one hidden layer. So what is this dense will do means it will construct the fully connected layer. That is, it will connect all your inputs and it will work out, it will connect towards it will assign weights for the each and every input. So that is what we are doing in the dense. It will just construct a network. Okay, so layer equal to dense of 128 comma name equal to fc1 inputs. So you are just passing the inputs for this particular layer. Then layer equal to batch normalization, name is equal to bz1 of layer. This is the second one you do it. Third one is applying the, so what they will do it in batch normalization means the input will be multiplied with the weight. After that, the result, whatever you get it, that will be stored in the second one. So you are just supplying the weight and passing, multiplying the weight with the input. That is whatever we do to the filter. That is what is happening here. Okay. So the filter value will be multiplied into your input, and whatever the result that you are getting, that is the second one, batch normalization. After getting this batch normalization, what we have done, we have applied the ReLU function, right? That is called as the activation. So just compare your concept with the program. So first line will give you the input. Second line will give you the result for the convolute layer. Third line will give you the result for the ReLU layer. That is, you are again converting the result into, that is, you are just eliminating all the non-negative values, right? For that, you are applying the activation function. So here we have selected the activation function is ReLU. So within the single quotes, whatever the activation name that you are passing, that particular technique will be applied. So here the function name is activation. Within the bracket, I have mentioned ReLU. So ReLU technique will be applied. This is just a name of the layer. Name equal to activation 1 means this is just a name of the function. So then I'm just passing the layer. Okay. So then dropout 0.3 name is equal to dropout 1 layer. So here I'm just constructing the featured map. Okay. After that, I'm just constructing the rectified map, right? This is the result. I will get it in the 4th layer. That is the 4th row. So once I have completed the 4 lines, I will be able to successfully execute the first hidden layer. So like this, just copy paste the same thing and construct the remaining layers. So I have just copy pasted all these things. Just change the function name alone. For example, here I have used the variable name as FC1, here FC2, FC3. So if you see there are 3 FC available, it means that I have constructed 3 hidden layers. So all the hidden layers consist of dense function, batch normalization, activation, dropout. Dense for constructing the input, batch normalization for getting the convolute layer, activation for getting the rectified, that is multiplying the ReLU. Then the 4th one, dropout for rectified feature map result. So after designing the hidden layer, I can directly go with the classification. So for classification, so I have constructed the final function, which is called as layer is equal to, it is after constructing all these 3. I am just designing the final layer. So dense 1 name equal to output layer. So initially we have designed input layer, and I have designed 3 hidden layers. Now I have the output layer. I have to design the output layer also. So I'm calling the dense function again to design the output layer. I'm giving 1 because only 1 output layer I'm going to have, name equal to output layer. Then I'm just passing the function as layer. Here also I need the activation function. If you recollect, we have applied the softmax. Okay, so you can go with any type of activation function here. So here they have applied sigmoid, or else you can go with the softmax activation function also. So then final model has been constructed. Model is equal to inputs, output equal to layer. So you're just passing the layer object here as the outputs and inputs as the inputs. Now, once you have constructed the model, you return the model. So what I have done, I have just designed my neural network. That's all. So no, I have not executed the neural network. I have not trained. I have just designed the neural network. If you want to see your model equal to NN, model equal to summary. If you execute this particular method, you will be able to see how you have designed the whole neural network. Maybe the description about your neural network. Okay, how many networks you have, how many hidden layers you have, like that you'll be able to see the summary of your neural network. Then finally, you need something to train your neural network, right? So neural network training can be done with the help of a function known as model.compile. So now my neural network is ready with a variable name known as model. Just call the method known as .compile. So here the compile contains three parameters. The first parameter is known as loss. Second parameter is optimizer. Third one metrics. So loss, I can apply the loss function to eliminate the loss present in the training. So here there are a lot of loss functions available. One such is binary underscore cross entropy. Please browse and see how many loss functions are available. Optimizer equal to Adam. So this is also, these two things are separate concept, avoiding the loss and improving the accuracy. Suppose if you want to improve the accuracy of your neural network or deep learning model, in that case, you just fine tune the loss function and fine tune the optimizer. Change the optimizer or change the types of optimizers available and apply different loss functions available so that your model accuracy can be much better. So for the compile method, you just pass the loss function and optimizer. Adam is one of the best known optimizer that is available, and metrics equal to accuracy. So I just want to know only about the accuracy. So here I have passed accuracy. So I will get the result as accuracy. Then I explained you there is a concept known as early stopping is available in order to stop the iteration. So I'm calling the method known as reduce LR on plateau and early stopping. These two methods are available in Keras framework. So this will avoid the too much time in execution. So I'm calling these two methods. Here I'm passing these two functions in the model.fit. So model.fit is the only method that is expected to train your neural network. So maybe you might have come across the method known as fit in machine learning whenever you apply Python. So in the whole Python, if you know the method about fit, always this fit method is used for training the model. So model.fit is used for training. So here I need to pass the X value, Y value, both of training data set. So X train, Y train I have passed. Epochs equal to 200. So to 200 iterations, this particular algorithm will be executed. This particular whole algorithm will be executed. And validation data also I have designed. Maybe in the first step, after designing the input, I have designed the validation also. If you want, you can leave this validation data. Then callbacks equal to reduce LR early stopping. These variables I'm just passing inside the fit method. So whenever there exists a particular accuracy within the minimum iteration, this particular callback procedure will be executed and algorithm will be stopped. So it will not execute till the 200th iteration. It will stop in between if there is a very good accuracy. Then verbose, I'm just passing to make the accuracy as a constant one. So all these methods are available in the fit. Okay. Then you go ahead with estimating the that is model accuracy. So these are all the procedures that I can use to call the accuracy. It is just you call the method known as accuracy underscore score, then classification underscore report. These two methods are widely used. So here I have written to 3 to 4 lines of code because I just want to get the report in a different format, in a row column format. That is why I have written the code something like this. Otherwise, you just call the method simply accuracy underscore score, classification underscore report. So accuracy underscore score contains two parameters. There is one is actual value, another one is predicted value. So Y contains the actual value, Y underscore prediction contains the predicted value. Okay. So now we have trained the whole model by using fit method. If I want to apply prediction, then you have to call the method model.predict and pass the value X. Okay. Now your predicted results are stored in the Y underscore prediction. So now what
Excuse
would
me,
happen?
madam. Excuse me, madam.
Yes, sir.
Madam, already time over. You
Yes, sir.
take a 5 or 10 minutes. Okay.
Sure, sir. No, I'm going to complete, sir.
Oh.
So now the predicted results are stored in y underscore prediction. So now accuracy score, you can do it by comparing the actual value and the predicted value. So y is the actual value, y underscore prediction is the predicted value. So if you call the method accuracy underscore score, you will be able to get what is the accuracy between the actual value and the predicted value. Similarly, classification underscore report is also available to get the whole summary of the neural network model. So this is the result I got it whenever I get execute the whole thing. So classification report, they will give you the weighted average, macro average, and accuracy percentage, everything in a tabular format. And other parameters I think you might have heard about, like precision, recall, F1 score, support value, all these are classification parameters for measuring the accuracy level, right? So beyond accuracy, please measure these parameters also: precision, recall, F1 score, support. So you can use all these values whenever you write the consolidated report for your model. So I think this is enough for a neural network. I will just share this program as well as diabetics data set. Please execute the program and see. Probably you'll be able to understand how the whole neural network program has been used. Similarly, in between the charts also you can see. Please execute the whole program. I'll share the notebook as well as the data set. Load the data set and then you'll be able to execute the program. So that's it from my side, sir. Any queries you can ask. Otherwise, we can wind up the session.
Ma'am, actually, network is there, ma'am. Neural network is there. We are having our own data. We are inputting the data and we are getting that output based on the setups what we are giving through our codings. Am I correct, ma'am?
Yes, sir. Yes, ma'am. Yes.
That, different layers what and all we are using.
Yes.
And that too, there I have one doubt, ma'am. In NN function, you have given 3 layers, like repeatedly you have given. But in that case, so will it be repeated, madam? Like,
no, madam. The output of one hidden layer will be given as input to the second hidden layer. Means the coding is same, but the output of the first layer will be given as input to the second layer. So execution wise, the result will vary.
So what is going to be there in the hidden layer, madam? The first 3 things, that is including a reload and every all in
the normal activation functions and all same, madam. But the output of the hidden layer 1 will be given as input to the hidden layer 2. So automatically the results will vary, madam. Something like differentiation. If we take differentiation every time, what will happen?
All 3. That is first 3 statements is for one hidden layer.
No, first 4 statements.
Okay.
Then 4 statements, madam.
Ma'am, okay, ma'am. That's clear now. Ma'am, one other question is, as I asked you, network is there. We are giving that input and we are getting that input based on that arrangements of the layers. Okay,
yes.
How many number? Okay, ma'am. So here from the images, it is extracting that the features. It is extracting the features, and based on that, it is calculating that relationship between correlation between that features.
Yeah.
It is happening. So my doubt is it possible of that is the nodes nodes in that network, like neurons in that network? Shall we assign some values to that neurons now for designing our own neural network instead of having that built-in neural network passing that input and getting that result? Shall we design our own based on the value?
Without data set, you are saying? Without data set?
Any data set. So our own data set we will be having with us. So that data set we want to get the result, ma'am. So for that, what I'm asking is, instead of going that ready-built network, so shall we design? So this will be the feature value. So that the combination of so many nodes.
Yeah, you can do it, madam. You can do it. No problem. You can do it.
Our own network, ma'am.
Yeah, you can do it. That is, instead of calling the step-by-step procedure, dense batch normalization, activation, dropout, you can go with your own design, madam. Possible.
Okay. What should be the value of that node in network, ma'am? Each node. How to assign? Shall we apply any formula like feature to?
Yeah, basically you need to come up with your own activation function. You need to select which particular feature needs to be given more weight. So that and all you have to design, madam.
So nodes are taking that features.
Yes, each and every nodes are considered to be a feature.
100 features are there, 100 nodes we have to have it.
Exactly. But don't go with 100 nodes. That is why I asked you to find out the correlation of the attributes. We have done it right by using heat map. So whichever the attributes that are highly correlated, consider those attributes as the input nodes. Don't go with all the nodes blindly. If you take 100 nodes, what will happen? The processing will be very high. Don't go with 100 nodes. Find out which attributes are highly correlated. Just eliminate the remaining nodes, and whichever the attributes that are highly correlated, consider those attributes as the input nodes. That is why we are finding the correlation.
Ma'am, is there any work available like that is customized network, ma'am? Customized network.
All the people, those who are doing research, they are doing customized network only, not a standard one. If you search any research paper, if you search for neural network applications research work, all they are building the customized network only. They are constructing. It's very simple, madam. Whatever the data set you have, identify which particular input you want to have as the important attributes. Find out the correlation. Construct those inputs as the input nodes. Then you go with the construction of the hidden layer. Determine your own activation function. Based on that, you proceed.
Yeah, that is that matrix or activation layer.
First thing is you need to identify the correlation. What is the correlation, and find out which attributes are very much important. Based on that, you construct your own network. That is the thing that we have to do normally. Here it's a sample program. That's why I have applied all the features as main.
Activation function other than this list of activation functions.
You can. Yes, madam. I will share that Word document also. Other than reload, you can go with any activity.
You gave a maximizing. So instead of going that averaging also you told that. So instead of that minimizing that is minimized value also we can select.
Yes, madam. Yes.
That also we can try.
That also you can select it. Yes. Here, madam, I can able to understand your question. Here I have applied the framework. Got it? I have applied the Keras framework. Keras framework contains the built-in methods like dense, batch normalization, activation, dropout. Okay. But if you go with writing the program by using Python from the scratch for building the neural network, then you can directly apply all the things.
Yes, ma'am. That AlexNet.
Write the code from the scratch. Here, it's a Keras framework, Tensorflow frameworks. What they are doing is they are just giving you the function directly, and they are asking you to supply only the activation function. They are asking you to supply only the input-output activation function. Just a ready-made one. So that is the role of the frameworks. So this is a Keras framework. So everything is available by default, easy for you to do experiments. So before doing investigation, execute your program using Keras, do some sort of investigation, and after that you can write your program from the scratch. You can build your own neural network from the scratch. Not only in Python, you can also do it in C or any programming language you can use, madam, to write the program from the scratch.
That AlexNet,
This is a framework, so everything is a limited functionality. They have a method, and you are just passing the values. That's all you are doing. Like calculating the square root by using math.square. Similar to that.
Understanding, we can use it.
Yes. For understanding, you can go with a framework. But if you are doing research, don't go with frameworks. Better you write the program from the scratch. That will help you.
Okay, ma'am. In what situation we can go for that AlexNet, VGG, that base instead of that CNN, we can go for that specific version of the CNN also. Am I correct, ma'am?
A recurrent neural network, you are saying?
No, CNN, the CNN only, that AlexNet CNN.
It is, they are saying CNN will follow certain fixed things, madam. Whenever you are applying ReLU and Softmax activation function, then definitely it is a convolution neural network. There is a CNN is mainly applied when you want to perform the image related classification. If you are doing image classification, better go with the convolutional neural network, because they are applying the filter techniques, all those things. So CNN is best suitable for image related classification.
But we can customize by our own arrangements of this stages. We can make it on our own. That AlexNet, VGG16, all these networks also can be made it out.
Yeah, can.
Okay,
ma'am.
Yes,
ma'am. This is the application. This is the example for binary classification. Is it, ma'am?
Exactly. 2 outcomes I have designed. So binary classification.
Here you are creating your own neural network. Is it, ma'am?
Yes, ma'am. Yes. By using Keras framework. I have used Keras framework for constructing the neural network.
Oh,
If
okay,
you
ma'am.
want to go with other neural networks, other frameworks also, TensorFlow is available, Deep Learning 4J is available. There are a lot of open source frameworks available. For research also, you can go with no issues. You can compare what is the result of Keras, what is the result of TensorFlow, like that also you can do research. There is no issues in using the framework. But as madam said, if you want to do some kind of customization, that is not possible in the frameworks. You cannot do it all types of customization.
Yes.
Okay.
Because the functions are ready-made, you can supply only the input. If you want to customize your input, in that case, you can write the program from the scratch only.
Okay, ma'am. Thank you,
Lots
ma'am.
of frameworks will help you to understand the concept of neural network much better way.
Thank,
Yes,
thank
sir.
you. Thank you, madam. Wonderful session, madam.
Thank you, sir.
Thank you.
Thank you
I am
so
very
much.
happy. I am very happy, madam.
Thank you, sir. So I
Thank
will share the PPT, sir. I will send you the questions by 2 p.m., sir. I will send all the questions to you in a Word document for the assignment purpose. Before that, I will share you all the PPT as well as the materials I have it.
Okay, madam. Thank you, madam.
Programs,
Thank you.
everything. Thank you all. Thank you
Thank
so
you.
much.
Thank you, ma'am.
Thanks for